next we're going to talk about section 3.4. 3.4 is all about measures of position. There are two different types of measures of position. This is where we're trying to find where a piece of data is located in a data set, its position in the data set, and that's going to be Z-scores. These are also referred to as standard scores, and quartiles, percentages, and deciles. So let's talk about this. First thing I want to talk about is Z-scores, because Z-scores relate to the normal curve and the standard deviation, which are the previous two sections we just talked about. So Z-scores are used to compare numbers that come from different data sets. So, for instance, how does a 75 on a history test compare to a 69 on a calculus test? Which score was better? One needs more information to answer this question. So what we need to know the mean of each set of scores and the standard deviation of each set of scores. We're always going to need the mean and the standard deviation. So standard scores, also known as Z-scores, are our sample value minus our population mean divided by the standard deviation of our population. This gives us our standard score. And it's possible to have a standard score that is value, just negative, just so you know, because there are some values that are less than the mean. About half the values, right? So let's calculate some Z-scores. So the Stanford-Binet IQ test is scaled so that its scores have a mean of 100 and a standard deviation of 15. Let's find the Z-scores for a value of 85, 100, and 125. So Z is our sample value, not with a bar over it, minus our population mean over our standard deviation. So for 85, I would have 85 minus 100 divided by 15. So I get negative 15 divided by 15, which is negative 1. When I have a Z-score of 100, when I have an IQ score of 100, I take 100 minus our population mean, which is also 100, divided by 15. That's going to give me 0 over 15, so I have a Z-score of 0. And if I have an IQ of 125 minus 100 over 15, that gives me 25 over 15, which is 1.6 with a bar over it. So why don't we go ahead and say, where do these fall in a normal distribution? So I've got 100, this is my mean. 85 is over here, it's one standard deviation below, and 125 is over here, I guess. It's like 1.6 standard deviations above the mean. Now, this doesn't tell me anything about their position in the set of data. Well, the 0 kind of tells me it's in the middle. But there's one thing I'm missing when working with Z-scores. Once we know a Z-score of a data value, okay, the properties of a normal distribution allow us to find its percentile, so its location in the distribution. It allows us to determine what percentage of values are above or below a given data value. And we do this with a Z-score table. I have posted one in this class module, or you can Google one. They're all pretty much the same. So, what does a Z-table look like? Let me show you. So here we have a Z-table. As you can see, we have Z values that are negative and Z values that are positive. So on the left, this is when the value of your piece of data is below the mean. And over here is when your data value is above the mean. And as you can see, right at the middle, at 0, if you had a Z-score of 0, right at the middle, that's when you have half of the data below you. Okay? How do I read a Z-table? So if we go to this previous problem, I found the Z-scores. I found that 85 had a Z-score of -1, mean 100 had a Z-score of 0, and 125 had a Z-score of, let's go, 1.67. And I want to find the percentiles that relate to the scores, to the Z-scores we just found. So let's go to our Z-table. So first things first, 85 let me draw my own little normal curve. So at 85 has a z-score of 1. So I'm going to go to -1 right here, -1.1. I find 0.1587. What does that tell me? It tells me, as you can see here, the area to the left. So the area to the left of 85 is 0.1587. What does that mean? 85 marks the 16th, because you got to round up, percentile. What does that mean? 16% of the values are less than 85. So now let's talk about z-score of 0. What's the meaning of a z-score of 0? Well, I go over here. Here's 0. I go to 0, 0, because 100 had a z-score of 0. That's a 0.50. That means that 50% of the data values are less than 100. So 100 marks the 50th percentile, which makes sense, right? It's the mean. It's the smack dab in the middle. Next, how about orange? Next, let's look at 125. Remember 125? Oops. What happened? No. Okay, phew. 125 had a z-score of 1.67. So I go to 1.6, and I go all the way over to 7, and I get 0.9525. So that means that the area to the left of 125 is 0.9525. So we got to round that up. So 125 marks the 95th percentile. That means 96th percentile. That means 96% of the values were less than 125. So this is how we use a z-table. So let's go through another example. Cholesterol levels in men 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. What is the percentile for a 20-year-old man with a cholesterol level of 190? So first I need to calculate my z-score, which is my sample minus the mean over our standard deviations. So I'm going to take... I did this math ahead of time. Where'd it go? There. Okay, I'm going to take 190 minus 178 over 41, and that's going to give me 0.293. Now, this is not our percentile. This is our z-score. We have to go to a z-table. So I have 0.293. We're going to round that to 0.29. So now I go to the z-table, and I go to 0.2. Where'd it go? All the way over to 0.29, that's 0.6141. So I have a z-table value of 0.6141. So what does that tell me? That tells me that the percentile of this gentleman is the 62nd percentile. That means that 62% of cholesterol levels are less than his. Next, what cholesterol level corresponds to the 90th percentile? The percentile at which treatment is necessary. So now I'm given the percentile, and I need to find my X value. I know two things. I know my mean, I know my standard deviation, but I can also know my z if I go to a z-table and find the closest value to 0.90. So let's do that. Where's the closest value to 0.90? It's going to be greater than 0.5, so it's on the positive side. And you just want to find the closest value to 0.90. I think it's this one right here, this 0.8997. So this is at 1.28. So now I know my z-score is 1.28. And I can solve for x. I'm going to multiply both sides by 41. And then I need to add 178. So let's go ahead and do that, and I will get that 230.48 equals x. But I've got to round up, right? So 231 equals x. So the level of cholesterol that corresponds to the 90th percentile is 231. So let's answer two questions here. Cholesterol levels in men, again, same distribution. And I want to know what's the percentage of men in this age range that has a cholesterol level of 188 or lower. So the first thing I do is I calculate my Z-score. 188 minus 178 over 41. That equals 0.244. So 0.24. I take that to my Z table. So we go to 0.24, and I find a Z table value of 0.5948. So I'm going to go ahead and say that 60%, let's round up, 60% of men have a cholesterol level of 188 or lower. Now, I want to know what percentage of men in this age range have a cholesterol level of 188 or higher. Well, I'm going to go ahead and take 1 minus 60, and that gives me 40%. So 40% have a level higher. Why does this work? Here's my mean. Here's 188. I know that the area over here was 0.5948, which I rounded to 0.60. So the area over here has to be 0.41 because the area under a normal curve has to equal 1. It's so nice. All right, next question is, what percentage of men in this age range have a cholesterol level between 188 and 192? So I have a value of 188 and I have a value of 192. So I'm trying to find the value in this little area right here. Well, I already know that to the left of 188 is an area of 0.5948. So if I go ahead and find the Z-score of 192, which would be all of this, and I subtract 0.5948, I will find the area in here. So the Z-score of 92 minus 188 divided by 178 divided by 41 is 0.34. And if I take that to the Z table, 0.34 gives me a value of 0.6331. So let's write that down. So I have a Z table value of 0.6331. So that's this area right here. This whole blue thing is 0.6331. And if I want to find the area right here, I have to take 0.6331 minus 0.5948, and I will get 0.0383. So about 3.8% of men are in this range. So Z-score. So if someone asks you ask you what a Z-score is or what a Z-score tells you, your answer should be that a Z-score is the number of standard deviations the original score is from the mean. If a Z-score is negative, then the original score is below the mean. And if the Z-score is positive, then the Z-score is above the mean.